Hello everyone, welcome back. One more nice simple question on center of mass taken from Pathfinder. So let's read the question. It looks simple, but it's not very simple. You need to do a bit of analysis. Not very complicated mathematically, but conceptual question. Let's read it. A small disk sliding on a frictionless horizontal floor. So small disk, I'm taking it as A, going on a frictionless horizontal floor with an unknown velocity. So velocity u is not known to us. I'm just taking it as u, and it collides head on, so no deflection, with another identical disk, meaning equal mass, same size, same mass, everything is same. Kept at rest. Initially, it is at rest on the floor. If the disk during a time interval tau, the first and the second disks cover distances s1 and s2 respectively. So they gave distances, but I am taking them as displacements. All right, because anyway they are not going to return back. Even if it is elastic collision, also A would come to rest and B goes back, goes in the same direction. E less than one, they will go together in the same direction only. Not necessarily together, but they go in the same direction. So there is no reversal path here. That is why whether it is distance or displacement doesn't matter. Magnitude of displacement, distance, okay here. Find possible values of initial velocity u. So that unknown velocity they said, right, u. We have to find the possible values of u of the first disk and also initial distance. So initially they are separated by some L distance. That's where we started timer. Then initial separation, let's say L. So after that, these guys have covered S1 and S2. So known quantities are S1, S2 and tau. S1, S2, tau are given, and we have to find the possible values of U and L in terms of that S1, S2 and tau. So they didn't mention the nature of the collision, whether it is elastic, inelastic. So the unknown I would take would be E, coefficient of restitution. And well, let's try to analyze the motion and try to see how we can proceed further. First, t equal to 0, separation was L, A was moving, B was stationary. At t equal to tau, collision happened already in between. So after collision, the disk B has covered S2 distance and disk 1 has covered S1 distance from the beginning, meaning covering L, and then additionally it has traveled some extra after the collision. So if you look at the geometry part of it, L plus S2, you look at the geometry. The initial position of A and final position of B, if you consider that separation between them is L plus S2, that has to be equal to S1 plus D. So that is the displacement of A and then final separation of D. Finally, when the separation between them is D, let us assume. So D is also unknown. L is unknown, D is unknown. S1, S2 are known to us. So this is one equation. Hopefully, it will be helpful for us. Let's go on further. So then what do we have? Whenever you have collision, we try to apply conservation of linear momentum. That's one possibility. So m into u equals to m into v1 plus m into v2. Conservation of linear momentum, I have applied it. And coefficient of restitution. Speed of approach is u. E times the speed of approach is speed of separation. That is v2 minus v1. v2 is faster than v1. Okay. So solving these two equations, 2 and 3, m gets cancelled anyway. So you will get v2 and v1. v2 will be proportional to 1 plus e and v1 will be proportional to 1 minus e. And again, here also there are so many unknowns. You see, v1, v2 are not known, e is unknown, u is also unknown. So many unknown, still not very clear whether we are going in correct direction or not. But we have written those equations. Now, what else can we apply? I'm thinking about motion of center of mass also. That is what I tried next. So center of mass motion, meaning I'll find displacement of center of mass, I find velocity of center of mass. Acceleration of center of mass will be zero only because there is no external force here on horizontal direction. Vertically mg normal reaction, they balance out anyway. So first displacement of center of mass is m1 s1 plus m2 s2 upon m1 plus m2. If you write masses are equal, you will get this. So this is something confident because s1 s2 they had given. So displacement of center of mass s1 plus s2 by 2 is something which has got concrete value because not many unknowns, only SCM is unknown, that's all. Okay, same way let us write velocity of center of mass. M into u was the initial momentum and total momentum will always be that only, divided by total mass gives you u by 2, that is velocity of center of mass. That is also okay, one unknown we have it. And now if I apply time, VCM into time is the displacement of center of mass because u is acceleration of center of mass 0. VCM is u by 2, you substitute there. Displacement of center of mass is s1 plus s2 by 2, and if you substitute them, you will get u equal to s1 plus s2 by tau. Very good, nice. So I was not expecting until that time because involving so many unknowns. So suddenly you see that u has got a value, one fixed value, in fact, not possible value. S1 plus S2 by tau. S1 is given, S2 is given, tau is given. So there's nothing to vary here. So u has no possible values, so many possible values. In fact, only one possible value you have, and that is S1 plus S2 upon tau. So u is decided. One part of the problem is solved. Now L we need to focus on. For that, I'll try to look at time of travel. So maybe you can go back up and again check it. So time of travel is first A has to travel L distance covering with a speed u. So that will take L by u time. After that, whatever A moves, forget about A, focus on B. B will have to cover S2 distance. S2 upon V2 will be the time after collision there. Time before collision is L by U. Time after collision will be S2 by V2. So if I use them, total time of travel is L by U before collision, S2 by V2 after collision. So you sum it up, you will get the total time of travel, and V2 anyway we got it here. So V2 I will use it here. So this V2 I have substituted. Then by from here little bit of manipulation I will get L here. Very good. And here you see u into tau we got it na already. U into tau will be S1 plus S2. That also I will substitute. So S1 plus S2 minus 2S2 upon 1 plus E. Very nice. So we only one unknown is there, and that is E. So I'm assuming that E is variable. You can take E can be any possible value from 0 to 1. Of course, super elastic collisions are also possible, but that is rare. Let's not consider that. That will happen only when there is some explosives and so on. So here we are considering that E is less than or equal to 1. Least possible value of E is 0 and maximum possible value of E is 1. That's the assumption we are taking. So in that particular case, if I take E value least, denominator least meaning fraction becomes maximum. Maximum when you are subtracting, you will get the minimum value. So that is going to be S1 plus S2. And so you see perfectly inelastic collision meaning what? After collision, they will go together. That means separation becomes 0. You go back up there, you put D equal to 0 here. Right? You put D equal to 0, L equal to S1 minus S2. So that is what you will have. That is minimum separation of L. When will you have maximum separation of L? When the other extreme of E is given. E equal to 1 you substitute. Then you are getting that L max equal to S1 there. So what is happening when E equal to 1? What happens? A comes to rest. A will not move. A will be here only. B moves. Then S1 equal to L you will have it. So that is also fine. So that means L has possible values. It can be anywhere between S1 minus S2 least value to S1 depending on the E value. E is the coefficient of restitution that they had not mentioned. But whatever may be the value of E, U is always S1 plus S2 upon tau because that has been measured or calculated with the help of center of mass motion, which is independent of E there. So it's a very beautiful question, simple question, seemingly confusing, not going anywhere, looks like that up to certain time, but suddenly you get that you're getting the results. So it's a very interesting question. I hope you enjoyed it. So with that, I'll conclude here. So thank you very much for your time. Until next time, goodbye.